Hello everyone, my name is Sudhanshu Shukla. I welcome you all in my YouTube channel Let's Talk. Here I am with the 13th part of running video series. This part contains solution of first 25 questions of Sagar University 2020 question paper. This video series will be helpful for every geology student. So before starting today's video, if you are new to the channel, please make sure to subscribe and share among your friends. So let's start. The first question says, the purpose of study of environmental geology is to understand. So first of all, what is environmental geology? Environmental geology is an applied science that involves the study of interaction of humans with the geologic environment, including the biosphere, the lithosphere and the hydrosphere. So it is clear from the definition itself that the purpose of study of environmental geology is clearly to understand the biosphere, the lithosphere and the hydrosphere. So the correct answer of this question will be C. But origin of Earth in geology itself, geology is the scientific study of the origin, history, structure, and composition of the Earth. Okay. So as far as the question is concerned, environmental geology is concerned, it involves the understanding of the biosphere, lithosphere, and hydrosphere. Okay. So next question is, the silicate minerals classified based on different linkages of silicate tetrahedra. So, silicate minerals classified on the basis of different linkages of silicate tetrahedra are tetrosilicate, in which silicon oxygen ratio is 1:2, seed silicate, or these are also known as phyllosilicate, in which Si:0 ratio is 2:5. Inosilicate is divided into two parts. These are also known as chain silicate. Okay, and these are divided into two parts, single chain silicate and double chain silicate. In single chain silicate, pyroxenes comes under single chain silicate and amphiboles comes under double chain silicate. Ratio of Si:0 in single chain silicate is 1:3, while in double chain silicate it is 4:11. Okay, next is cyclosilicate. These are also known as ring silicate and Si:0 ratio is 1:3. Next is nesosilicate, in which Si:0 ratio is 1:4. Olivine family comes under this. The example is olivine family. And next is sorosilicate, in which Si:0 ratio is 2:7. So the classes of, you can say there are 6 classes of silicate minerals: tectosilicate, seed silicate, inosilicate, cyclosilicate, neosilicate and sorosilicate, on the basis of different linkages of silicate tetrahedra. So the correct answer of this question will be A. Next question says, what is the composition of andradite? So first of all, andradite belongs to garnet group of minerals, and garnet group of minerals are categorized into two series. First one is pyrrolspite series and second one is eugrandite series. So clearly andradite belongs to eugrandite series, and the composition of andradite is Ca3Fe whole twice Si3O12, while this is Mn3Al2Si3O12 is composition of spessartine and it belongs to pyrrolspite series. Coming to Mg3Al2Si3O12, this is composition of pyro, and Ca3Al2Si3O12, this also belongs to eugrandite series. This Gr represent grossular, and the composition of this composition is of grossular. So as far as andradite is concerned, the composition of andradite is this: Ca3Fe whole twice, some amount of titanium is also present, and Si3O12. So this will be the correct answer. Next question says, phyllosilicate 14 angstrom is an example of. So as we know, phyllosilicates are also known as seed silicates. Okay, and the Si:0 ratio is 2:5. Okay, and in the option itself, chlorite, mica and kaolinite, all these belongs to phyllosilicate, in which chlorite have 14 angstrom dimension, and mica type have 10 angstrom, and kaolinite is an example of 7 angstrom. Okay, so the question is asking about 14 angstrom, phyllosilicate 14 angstrom. So the correct answer will be chlorite type. If this question were asking about 10 angstrom, then the answer will be mica type, and if the question were asking about 7 angstrom, then the answer will be your kaolinite type. Next question says, the book Principles of Geology is written by. So, principle of geology is an attempt to explain the changes of Earth's surface that took place earlier, and it is written by Scottish geologist Charles Lyell. That was first published in 3 volumes from 1830 to 1833. So, the book of Principles of Geology is written by Charles Lyell, while James Hutton wrote the book The Theory of the Earth approximately 50 to 70 years earlier than Charles Lyell. So, a book written by James Hutton is Theory of the Earth, while Charles Lyell wrote the book Principle of Geology. So, as far as the Principle of Geology is concerned, this book is written by Charles Lyell. Next question says, the crust mental boundary is referred to as the. So, as you all know, the crust mental boundary is known as Mohorovich's discontinuity, and its average depth is approximately 35 kilometer. 35 kilometer, 30 to 40 kilometer average depth below the continents, or you can say stable continents, but below the mountains like Himalayas, this depth will range approximately about 70 to 90 kilometer. Now, in Lehman seismic discontinuity, this is the boundary between outer core and inner core. Coming to Gutenberg this seismic discontinuity, this is discontinuity, or you can say this is the boundary that separate mantle and core. You can say lower mantle from outer core. This is known as Gutenberg seismic discontinuity. At 670 km seismic discontinuity, coordination of SI in mantle silicates changes from the familiar fourfold to sixfold. These are known as discontinuities. You can say seismic, or you can say seismic discontinuities, because in these boundary the velocity of seismic waves changes, either increases or decreases. That's why these are known as discontinuities. So as far as crust mantle boundary is concerned, this is Mohorovich's discontinuity. Now next question says, the radius of the earth at the equator is. So this is a very basic question. If you are a geology student, you should know the radius of earth not only at equator but also as polar radius and also its average radius. So the equatorial radius of the earth is 6378 kilometer. Its polar radius is 6357 kilometer, and the average radius of earth is considered as 6371 kilometer. So these are the three radius of earth that every geology student should know. So the question is asking about the radius of earth at the equator. So the correct answer will be 6378 kilometer. Other options are out of the box. If the question were asking about the radius of earth at the polar, then the answer would be 6357 kilometer, and the average radius of the earth is 6371 kilometer. So if you see, the difference between equatorial radius and polar radius of earth is approximately 21 to 22 kilometer. Okay. So as far as the radius of earth at equator is concerned, the correct answer is 6378 kilometer. Next question says, the continental crust is 30 to 50 kilometer thick and is mainly composed of less dense rocks like. So first of all, let's know about these options, that which of the following is less dense rock and which is the predominant rock or mainly composed in the crust. So first one is kimberlite. Kimberlite is ultramafic potassic igneous rock. It is hyperbasal and it is not that crust is mainly composed of. Okay. Next one is anthracite. Anthracite is not a igneous rock, or you can say anthracite is also not as abundant that it mainly composes the crust, because anthracite is a coal and it is the highest rank coal. Okay, next one is zircon. Zircon is a mineral and its chemical composition is ZrSiO4, and its ratio, if you see, is 1:4. So you can clearly say that this belongs to Nesosilicate. Now coming to granite, granite is less dense rock, and you know its density is approximately 2.75 gram per centimeter cube, and as you all know, the continental crust has also density of approximately 2.7 gram per centimeter cube. So granite is the rock that is mainly composed in continental crust, or you can say continental crust is mainly composed of granitic rock, more than, I think, more than 90% of the crust as per data in a book. Next question is, 90% not only granite, okay, 90% of the rock is of 90% of the crust is composed of igneous rock. Now it may be basalt also or granite. Now next question is, which may be a primitive magma? So first of all, what is primitive magma? Primitive magma is a magma that has been relatively unmodified or unchanged by differentiation process after leaving its source. And the criteria that help in identifying a primitive magma are: the first one is high MgO weight percentage, second one is low SiO2 content, and third one is low alkali oxide. These all indicate that a magma will be primitive magma. Okay, so considering first one, granite, we all know that granite have a high silica content. Okay, greater than 66%, or this is acidic igneous rock, so it will have a greater silica content. And coming to dacite, dacite also have a sufficient amount of silica content, and it does not, and it also does not have high MgO weight percentage. So this will also not be a primitive magma, and granite will also not be a primitive magma because it is a acidic igneous rock, and it have high silica content and low MgO weight percentage. Now coming to basalt, basalt is a basic rock, so it is clear, though it have a medium silica, moderate silica content, but it have high alkali oxides. So, and as compared to picrite, picrite is a type of basalt. Picrite is also a type of basalt, but it is olivine rich basalt. Okay, it is olivine rich basalt. Olivine rich basalt with MgO weight percentage, greater than 18%. Okay, and also Na2O K2O, that is alkali oxide, and these are from 1 to 3%. So clearly picritic magma, first of all, its MgO percentage is greater than 18%, its alkali oxides percentage is from 1 to 3%. So this is low, this is high, and these are also does not have a high silica content, that is these are of low silica content. So all these characteristics shows that picritic magma may be a primitive magma, but basalt will not be primitive magma as if we compare these two options. Okay, because picritic magma have more MgO weight percentage than basalt, and also okay, and also low silica content than basalt. So the correct answer of this question will be picritic magma. Next question says, porphyritic texture in a rock indicates. So first of all, porphyritic texture, it is an inequigranular texture or inequigranular magmatic texture made up of two grain sizes. Bimodal texture means that is made up of two grain sizes in which large crystals are called as phenocryst, and these are embedded in fine grained or glassy matrix, which is known as ground mass. Now, from definition, it is clear that porphyritic texture is composed of two grain sizes which represent two stages of cooling, because one stage of cooling will give rise to crystals of only one grain size. Now, what happens is that slow cooling followed by rapid cooling give rise to, first one is slow cooling. Slow cooling gives rise to formation of larger crystals that are known as phenocryst, and then followed by rapid cooling, which give rise to formation of fine grain matrix or glassy matrix. Okay, so it is clear from the definition itself that porphyritic texture in a rock indicates two stage of cooling. Now, single stage of cooling, or you can say single stage of crystallization, will not give rise to bimodal texture. Okay, incorporation of large crystal from other magma, this is the crystal that is incorporated from other magma are known as genocryst, and this is nothing to do with porphyritic texture. Now, segregation during a single cooling process, segregation gives rise to differentiation, and in this process may give rise to cumulative texture, which is formed by gravitative settling. Okay, now, so as far as porphyritic texture is concerned, it indicates two stages of cooling. Now, next question is, if the ground mass of a porphyritic texture. Now, in previous question, we have learned that this is an inequigranular texture and with that is made up of two grain sizes. First one is phenocryst, those are larger crystals, and second one is fine grained or glassy ground mass matrix. Now, if the ground mass of porphyritic texture in a rock is hemicrystalline, the texture is known as. Now, porphyritic texture is divided on the basis of ground mass present in that. Okay. Now, First one is vitrophyric texture. Vitrophyric, it is a type of porphyritic texture in which phenocrysts are embedded in glassy ground mass. So clearly in which ground mass is glassy, that texture is known as vitrophyric texture. And the name is, you can say vitro. Vitro means glass, and pyric refers to porphyritic texture. So in which porphyritic texture in which ground mass is glassy, that is known as vitrophyric. Next one is felsophoric. Felsophoric texture is that porphyritic texture in which ground mass is cryptocrystalline. Cryptocrystalline means ground mass are too small that can only be seen with the help of microscope. Next one is glomerophyritic texture. Glomerophyritic texture is formed by the process of synosis in which phenocrysts may cluster together and adhere by surface tension. Now, if clusters are of single mineral, then it is known as glomerophyritic, while multiple grain crystals of phenocrysts are known as cumulophyritic texture. So, this is nothing to do with the porphyritic texture, in which the ground mass is hemicrystalline. Now, next one is, and the remaining option is mesostasis. So, mesostasis is clearly the answer, and a porphyritic texture in which the ground mass is hemicrystalline is clearly mesostasis. Now, coming to next question. So, next question says, what is the characteristic mineralogical difference between norite and gabbro? So, to answer this question, you should know about norite and gabbro. So, norite is also a gabbroic rock, but the main difference is that norite contains orthopyroxene greater than clinopyroxene, and while gabbro contains clinopyroxene greater than orthopyroxene. You can say no, composition of norite is considered as orthopyroxene plus labradorite, and labradorite is a plegioclase feldspar, as we all know, and gabbro contains clinopyroxene plus labradorite. So in both these minerals, labradorite is present and labradorite is plegioclase feldspar, and the option second says plegioclase occurrence in only one. So this is incorrect because plegioclase occur in both norite and gabbro. Now next, both A and B are correct. Why? How it is possible? Because B is already incorrect, so this is also incorrect. Now difference in ortho and clinopyroxene. So this is the correct answer, because as we see, norite contains orthopyroxene plus labradorite. Here is orthopyroxene, while gabbro contains clinopyroxene plus labradorite. So here is clinopyroxene. So the main difference, or you can say characteristic mineralogical difference, is norite and gabbro is that one contains OPX and another contains CPX. So the correct answer will be A. Now, fourth option is shape and grain size of crystals are different. So this is totally out of the box because question is asking about mineralogical difference. Okay, or you can say mineralogical difference. And also, shape and grain size of crystals are not different in norite and gabbro. The main difference, characteristic difference, is that OPX and CPX. Now, coming to next question, and this question says lahergolite is a. Okay, so let's see this QAP, not QAP, this olivine, orthopyroxene, and CPX diagram, IUGS classification. Okay, in which lahergolite is right here. This is olivine, this is orthopyroxene, and this is clinopyroxene. Okay, now this is a percentage of olivine. Here it is 90%, here it is 40%. Okay, now these three corners are, this is dunite, which is monomineralic rock and containing greater than 90% olivine. This is orthopyroxenite, and this is also monomineralic rock and containing greater than 90% orthopyroxene. This is clinopyroxenite, and this is also monomineralic, and this contain greater than 90% clinopyroxene. Now coming to next, this part, this from dunite, from here to here 40%, this part, the rock that comes under this part are known as pedotite, while below this 40% in which olivine is less than 40%, these rocks are known as pyroxenite. Okay, and lahergolite comes under pedotite. So lahergolite is a pedotite. Herzbergite is also pedotite, wahorlite and dunite, these are all pedotite rock, while orthopyroxenite, olivine baptiterite and clinopyroxenite, these all are pyroxenites. And here it will be olivine orthopyroxenite, and here it will be olivine clinopyroxenite. So as far as lahergolite is concerned, this is a pedotite rock. Correct answer will be a pedotite. Now, next question says the process of cementation involves. Now, so what is cementation? A process of cementation takes place in sedimentary rock. Now, cementation is the process of hardening and welding of plastic sediments by the precipitation of minerals or fluid into the pore spaces of sediments. And the most common cementing materials are carbonate, silica, clay minerals, and iron oxides. So, process of cementation does not involve the process of cement production, but it involves the fluid trapped in the pores, which then crystallize and bind the unconsolidated sediments by filling up the pores of sediment. Okay, now it is the last stage of the formation of sedimentary rock. So, process of cementation involves fluids trapped in the pores. It does not involve weathering because as I told you that cementation is the last stage in the process of formation of sedimentary rock, and weathering, this is the first stage. It is the breakdown, or you can say disintegration or decomposition of rock into finer particles by mechanical, chemical and biological process, and this is the first step in the formation of sedimentary rock. So this cement weathering is the first step, while cementation is the last step in the formation of sedimentary rock. So as far as process of cementation is concerned, it involves fluids trapped in the pores. Now next question says, the mixed sediment water flows are termed as currents. Now first one is turbidity current. Turbidity current is clearly a gravity-driven turbid mixtures of sediment that are temporarily suspended in water. So this is clearly the definition of turbidity current, in which mixed sediment water flows are present. Now clear cut, I don't have any idea about this type of current and also normal current in geological literature. If you have, please guys, if you have any idea about this clear cut current and normal current, please comment down below. Next one is wind. Wind will not be correct answer because the question is asking about sediment to water flows. It is clearly mentioning that it's water flow, so wind will not be the correct answer. So only correct turbidity is correct. Next question says, lithification is the process of. So lithification composed of two words, lithos plus fication. Now lithos means rock and fication means the process of formation or action. So clearly lithification is the process of formation of rock. Now it involves changing of sediments into rock because lithification comes under sedimentary rock formation mechanism. Lithification is the mechanism in the formation of sedimentary rock, and it involves the changing of sediments into hard rock, compact rock. Okay, so lithification is the process of changing of sediments into rock. Now first option is rolling, sliding and hopping. These are all the types of bed load transported by action of wind. This also does not involve lithification because lithification is the process in which those sediments that are transported either by the action of wind or by water or by anything that is lithified and form rock. So this is also not comes under the lithification process, though it is a transportation process. So the correct answer of the lithification is changing of sediments into rock. Now next question is, hydrothermal deposits that result from high temperature fluids but at low pressure conditions is denoted as. So first of all, we should know about all these hydrothermal deposits: telethermal, genothermal, mesothermal and epithermal. So let's check one by one. So first one is telethermal. Telethermal are those deposits that formed at low pressure and as well as low temperature conditions. Next one is genothermal. Genothermal are those deposits that formed very close to the surface. Now, if these are very close to the surface, then the pressure condition will be low, but at elevated temperature, that is high temperature. So, genothermal formed under low pressure but high temperature condition. Next one is mesothermal. Mesothermal deposits are those that formed at intermediate pressure and temperature that ranges between 200 to 300 degrees Celsius. Next one is epithermal. Epithermal deposits are those that occur or that form in low pressure condition and temperature ranging from 50 to 200 degrees Celsius. Now coming back to the question is asking about those hydrothermal deposits that result from high temperature fluids but at low pressure. So among these, genothermal is the only one that form under low pressure condition but high temperature condition. So the correct answer this question will be genothermal. Now next question is, manganese nodules occur at. So according to a text, Manganese nodule are one of the most unique products of deposition, and these are found spread on seafloor of every ocean and in some temperate lake also. So as per option, if we check, first one is continental slope. This is incorrect because manganese nodules are formed at the floor of ocean or sea floor of every ocean. Sea beach, this will also incorrect. Continental shelf, this will also incorrect. D, deep sea floor, this is the correct answer. Next question is, Sudbury in Canada is world famous for which ore? So Sudbury in Canada is world famous for rich deposits of nickel sulfide deposits. So let's check the option. First one is lead zinc ore, incorrect. Tungsten ore, incorrect. Nickel ore, yes, because Sudbury in Canada is world famous for nickel sulfide deposit. So the correct answer will be nickel ore. This is also incorrect. Now coming to next question. Chalybeate is a variety of one of the following minerals. So first of all, you should know what is chalybeate. Chalybeate is a pale yellow to brownish black mineral, consists of iron carbonate in hexagonal crystalline form. So two things to be noted, that chalybeate is iron carbonate and it crystallizes in hexagonal crystal system. Now next, let's check the options. First, let's say from goethite. Goethite is FeOOH, so this is not carbonate and clearly are not iron carbonate. So chalybeate will not be variety of goethite. This is, though this is ore of iron. Gypsum, gypsum is CaSO4.2H2O. This is also not the variety of chalybeate, will also not be variety of gypsum, though gypsum have three varieties: alabaster, selenite and satin spar. So chalybeate is also not the variety of gypsum. Next one is scheelite. Its composition of scheelite is CaWO4, that is, it is tungsten mineral, and clearly it is also not the variety of, or you can say chalybeate is also not the variety of scheelite. Next one is siderite, and you all know siderite is iron carbonate FeCO3, and it also crystallizes in hexagonal crystal system. So it is clear that chalybeate is will be variety of siderite. So the correct answer will be siderite. Next question says, which of the following is an industrial mineral? So first of all, what is industrial mineral? Industrial mineral are those non-metallic minerals that are utilized for industrial purposes, and this includes mica, asbestos, barite, talc, soapstone, bentonite and vermiculite. Now let's check the options. First one is bauxite. Bauxite is an ore of aluminum, and aluminum is itself a light metal, so it is a metal. And in definition, I have told you that industrial minerals are non-metallic minerals. Okay, so this will not be the correct answer. Next, monazite. Monazite is a radioactive metal. It is also a metal. This is not a non-metallic mineral, so this will not also not the correct answer. Next one is manganese ore. Manganese ore is a ferrous and allied metal, so this will not be the correct answer as per the definition. So the only one, mica, which is non-metallic and it is used in industries, basically or clearly in you can say in electrical industries. Okay, the mica is used widely, so it is a non-metallic mineral and it is utilized for industrial purposes, so mica will be the correct answer. Other than mica, other minerals like asbestos, barite, talc, bentonite and vermiculite, these are also industrial minerals. Now next question says, chalcopyrite is a, so first of all, what is composition of chalcopyrite? Chalcopyrite is CuFeS2. Okay, so this is composition of chalcopyrite, CuFeS2, in which copper is metal, Fe is also metal. So clearly in here there are two metals present. Now first one is simple ore. Simple ore are those ores that yield a single metal, but chalcopyrite contains two metals, copper and iron. So this is not the correct answer. Next one is metallic compound. Now metallic compound is a compound that contains one or more metal elements bonded to another element, but it typically contains a cation and anion. An example of metallic compounds are like AgNO3, H2O and CaCl2. Like in AgNO3, this is cation and NO3 will be act as anion. So chalcopyrite is also not a metallic compound. Next one is complex ore. Definition of complex ore tells us that these are ores that yield more than one metal. So chalcopyrite fits under definition of complex ore. So chalcopyrite will be complex ore. This is not ferrous ore. Okay, this might be confusing. that this should be ferrous ore, but this is not ferrous ore because it is, first of all, it is an ore of copper, as copper content is more in as compared to iron, and secondly copper is a non-ferrous metal. So this is a not this is not a ferrous ore, this is a complex ore. Next question is cat coal. Cat coal is a term used for coal with pyrite. So the correct answer of this will be coal with pyrite. Next question says Palana lignite deposit is of. Okay, so basically all the lignite deposit of India, or you can say other of the world, are of tertiary age. Now, Palana lignite deposit is one of them, and but the age of Palana lignite deposit is Eocene age. The lignite deposit of Miocene age is Neveli lignite deposit, and the coal deposit of Carboniferous age are basically of bituminous rank. Okay, not of lignite rank. All the lignite deposit are of tertiary rank. So as far as Palana lignite deposit is concerned, the age of Palana lignite deposit is Eocene. Next question is graphite deposits form large by. So graphite is mainly found in metamorphic rocks like gneisses, schist, marble, quartzite and altered coal beds. And graphite deposit is product of regional and contact metamorphism. So from here itself it is clear that graphite deposits form largely by metamorphism. So the correct answer of it will be metamorphism. Hope you guys like this video. If you like the video or you have any queries, please let me know in the comment section. And what was your favorite question or favorite topic that you have learned in today's video? Please don't forget to let me know in comment section. Also join my Telegram channel for daily quiz practices.